Hi, and welcome to the second part of this tutorial. Here we will mainly focus on deep learning methods, and we will be now discussing the dataset that we will use throughout the remainder. Alright, so let's dive right in. The dataset itself is one for named entity recognition, where the basic idea is that we chunk the sentence into individual tokens and have entities such as New York, which would be tagged as a city. And the goal of the model is then to identify the respective entities. The dataset was published by Müller et al. In 2021, and this is the respective publication. And for this data, we asked factory workers in the CIP to discuss problems they encountered during their working life. And what we then did, we collected the data, tokenized it into individual tokens, and started annotating it. For this, we used the BIO tagging scheme. B standing for begin, I for inner, and O for outer. So basically everything that is not an entity is tagged with an O, and everything that is an entity is tagged with the respective entity class, and B, which marks basically the beginning of an entity, and I, that marks any follow-up tokens that are also a part of the previous entity. So overall, we collected 80 dialogues across 2 domains, which you can see here. The first domain is industry, and the second one is machining, and identify 655 entities across both domains. And in total, we have 9 different entity types. So the data is provided here on Nextcloud. And you can download it, so you will definitely need the industry and Zerspannungs files, and also you need the embedding data, which we will come to in the next lesson. And after you download it, you will see that it is formatted in a strange name called kernel, and you will encounter this rather frequently in NLP datasets. So the basic idea is that everything is separated by a tab, and each line basically contains a token and several labels, and empty lines basically mark the end of a dialogue or of a document. So this is the dataset we will be using throughout the tutorial. And as you can see, so we have like lots of O tokens, which is rather typical for named entity recognition, since you only have like a couple of important entities that occur. And the challenging thing is that we want to predict the respective entity out of the abundance of O tokens.